Now we're going to see the variation of value of g due to rotation of the earth. We have already seen the variation of value of g due to the shape of the earth. That is, because of the change in the radius, because it is not spherical, we have seen at different locations we get different values of g. Now what happens because of the rotation of the earth? Now let us assume our earth is rotating with the angular velocity omega. So we know that earth rotates about its own axis. So let me take one axis. So earth is actually rotating something like this, but let me take it here. Now let me draw the earth, which will assume to be spherical. So let me draw the equator as well. So now let us assume a person is standing somewhere here. So he's not floating in the air, but he's at the surface here. So let me take this point as P. Now the radius of the earth is nothing but capital R. So let me draw that. So this is nothing but capital R. We can see that the person is actually rotating in a small circle here. So if I draw this circle, the person is rotating in this circle because the earth is moving about its own axis with an angular velocity omega. So if I draw the small radius and take it as say small r, so it will be something like this. So this is nothing but small r. So let me write it down as small r. Now we know that mg is nothing in this direction, that is towards the center of the earth, which is mg. So some part of its gravitational force will be used to provide the centripetal force because it is moving in a circle. Therefore, the object experiences a centrifugal force. So let me draw that force, this direction, which is nothing but, let me write it as FCF. So therefore, let me write mg dash, that is the apparent weight of this person at this point. So whatever component of FCF will be in this direction, that is to the normal, will decrease mg. So let us take the angle made by this person with the center of the earth as phi. Then even this angle will be phi because these are parallel lines. So this force will be nothing but FCF cos phi. So my mg dash will be equal to mg minus, this is the opposite force, this is in this direction and this is in the opposite direction. So mg minus FCF cos phi. Now what is my FCF? FCF is nothing but m omega square small r, the radius of this circle. So if you find a relation between small r and big R, this is phi. So even this angle will be phi because they are alternate angles because these two are parallel lines. So cos phi will be nothing but r by r. Or in other words, the small r is nothing but capital R into cos phi. We can see that here cos phi is equal to small r by capital R. This is the radius and this is the other radius. So this equation comes out to be mg dash is equal to mg minus m omega square r cos phi. Because m is common, let me cancel it out. I get the equation g dash is equal to g minus omega square r cos phi. Because omega square r is a constant, because it is the angular velocity of earth and this is the radius of the earth, you can calculate that. It comes out to be 0.0337 meter per second square. So my final equation is nothing but g dash is equal to g minus 0.0337 into cos phi. So let me look what will happen if the person is at the pole, that is here. If this would be my point P, that means phi is nothing but equal to pi by 2. So we know that cos pi by 2 is nothing but 0. Therefore, g dash will be equal to g. Therefore, at the poles, g dash is nothing but g itself. You can imagine this like this also. If the person is standing here, he is not rotating in any circle because he is stationary at that point. At any other point, we can see that the person would be moving in a circle. Therefore, there would exist a force which would pull him in the outward direction. So this is at the pole. What will happen at the equator? Now I know that cos phi is nothing but cos 0 because the angle will be 0. The person will be here. So it will be equal to 1. Therefore, g dash will be equal to g minus 0.0337. So we can say that g is least when the person is at the equator. So from this equation, we can see that if the person is near to the equator, g dash is minimum. So when a person moves from the pole to the equator, g keeps on decreasing. So g is maximum at the poles and minimum at the equator. So suppose the earth stops rotating, that means this omega is nothing but 0. Then we can see that clearly g dash at every point of the earth will be g itself. Because of the rotation, there would be this force which would be negating our mg. Therefore, we get a different value for g. So that you can imagine at pole what would happen. If the person is standing here, then he won't be moving in a circle. So there won't be any force to negate mg. But in case of equator, you can see that the radius is maximum. So there would be more force or centrifugal force which is pulling the person outwards. One special case here is, suppose my omega, that is the angular velocity of the earth, is equal to root of g by r, that is the radius of the earth. What will happen in this equation? I can see that g dash will be equal to g minus square of this, so it will be g by r into r cos phi. So this is nothing but g minus g cos phi. So suppose the person is at the equator. I know that my phi is equal to 0. That means cos phi will be equal to 1. That means my g dash is equal to 0. Suppose the angular velocity of the earth is this, that is root of g by r. That means the person at the equator will feel no acceleration due to gravity, or g dash at the equator, or I can write it as g equator, is equal to 0. So instead of 24 hours a day, we will be having only 1.41 hours a day. This can be calculated finding the value of omega. Just substitute g equal to 9.8 and the radius of the earth, which is 6,400 kilometers. You will get the time required to complete one rotation. So let us look at the problem next. We will understand how to apply this formula in various problems. So our problem states that what would be the angular velocity of the earth so that the bodies lying on the equator may appear weightless. That means our g dash should be equal to 0, or g equator should be equal to 0. we already seen this condition. We know that omega should be nothing but root of g by r. So if you find out, it is given that g is equal to 10, so let us take this as 10, and the radius of the earth is 6400 kilometers, so into 10 power 3, so that everything is in meters. This comes out to be 1.25 into 10 power minus 3 radian per second. So you directly have to remember this formula. The angular speed of the earth when the g dash is 0. Or you can derive this. We know that g dash is 0. So g minus omega square r, because he is in the equator, cos phi is 1. So omega square r equals g, or omega is root of g by r. Our next problem states that the speed with which the earth have to rotate on its axis so that the person on the equator would weight 3/5 as much as the present will be. So we know that g dash is equal to g minus r omega square. Cos phi is equal to 1 because again the person is on the equator. So we need the weight. So I'll multiply with m. I'll get mg dash is equal to mg minus mr omega square. So let me take this weight as w dash and this weight as w. So this will be w dash is equal to w minus mr omega square. Now it is given that the person should weigh 3/5 as much as the present. So w dash should be equal to 3/5 of mg, because we know that this is our true weight. So this will be 3/5 of mg. So if I substitute in the equation, 3/5 mg equals mg minus mr omega square, or mr omega square equals mg minus 3 by 5 mg, which is equal to 2 by 5 mg. So if I cancel out m, I'll get omega square equals 2 by 5 g divided by r. So if I find out this value, it comes out to be, so 2 into g is nothing but 9.8 divided by 5 into radius of the earth 6400 into 10 cube. If you calculate this, you will get 7.826 into 10 power minus 4. So if this is my omega, the weight of the person would be 3 by 5 mg. That's what we want. So our problem states that on a planet whose size is the same of that of the earth and mass is 4 times that of the earth, the energy needed to lift a 2 kg mass vertically upwards through 2 meter distance on the planet is. We know that a g is nothing but gm by r square. That is, the acceleration due to gravity depends on your mass and is inversely proportional to the square of the radius of the planet. So if this is the mass of the planet and this is the radius of the planet, we know that rp is same as the radius of the earth because it is given that the size is same, and mp is nothing but 4 times me. Therefore a new g dash will be equal to 4 times g, because if I substitute it here, this will be g me, which is 4 times divided by re square. This is nothing but our g of the earth. So we know that g dash is 4 times g. the value of g is given, so g dash will be nothing but 40 meter per second square. G is nothing but 10. So the energy required to lift 2 kg of mass through 2 distance will be m g dash into h. That is the force into h, which is equal to 2 into 40 into 2. So which is nothing but 160 joules. All you have to do is find the relation of g dash and g.